In this video, we'll explore a second special case called difference of squares. But before we explain what that means, let's first look at a few graphs. Pause the video and see what you notice about the equations of each graph compared to their x-intercepts. Notice how the number at the end of the equation compares to the x-intercepts. That number is a perfect square, and the x-intercepts are the square root of that number. Now let's change each equation to factored form. Pause the video again and think through what you notice about these equations. Did you notice all the equations have the same number in each set of parentheses, and it's the square root of the original number at the end of the original equations? In addition, notice how each equation has a plus in one set of parentheses and a minus in the other. We'll talk more about this in a moment, but let's move on to actually multiply the binomials in these equations along with a few others. Pause the video and use your favorite multiplying method to multiply all of these. If you need a head start, the first one is done for you. Here are the answers. Do you notice any patterns? Just like perfect square binomials, difference of squares binomials are special because they also give us a shortcut. If you notice, every one of these examples has terms that cancel each other out. Then the final result is just the first numbers in each parentheses multiplied by each other minus the second numbers in each parentheses multiplied by each other. Therefore, with this in mind, see if you can rewrite these binomials by using the shortcut only. Pause the video and give it a shot. Here are the answers. Again, since the binomials are the exact same except one has a minus and one has a plus, all we have to do is multiply the first terms in each parentheses and then multiply the second terms. Let's work backwards now. See if you can write the binomials that create these equations after multiplying. Pause the video and give it a shot. Here are the answers. This time we can take the square root of the first and second terms inside the parentheses and then put a plus and a minus in the parentheses. Let's go ahead and recap what we've seen. Difference of squares is a situation where the binomials look the exact same except one set of parentheses has a plus and the other has a minus. Then the result of multiplying these binomials is just multiplying the first and second terms and putting a minus in the middle. The reason this is called difference of squares is because there is a minus in the middle of the standard form equation, so that's where the word difference comes from. And the word squares comes from the fact that there is a perfect square both in the front of x and at the end of the equation. Therefore, to end this video, I'm going to leave you with 3 examples that are not difference of squares. Can you figure out why each one is not?